Good morning all of you. Now today we discuss one new topic that is called geometric progression. It is one of the important chapter in CA Foundation paper 3. Okay. See, first what are the points we discuss in this is, first we discuss the definition of geometric progression. Okay, how can we identify whether the given progression is in GP or not? First point we see that. After that, how to find out sum of n terms of GP. Okay, and how to find out sum of infinite terms of GP and some properties of geometric progression, and also we discuss some problems relating to geometric progression. Okay, see, first of all we see the definition of geometric progression. It means a progression in which each term is obtained by multiplying a constant number to its preceding term, then the resulting progression in GP. That means, let us see one example. Okay, let us take the number 2 and we take one more number 2, multiply this 2 to the first term, hence we will get 4, 4 2s are 8, 8 2s are 16 and so on. Obviously this progression in GP. Okay, see, let us take one more progression, 3, 9, 27, so on like this. How can you say that this following progression in GP means? Let us check the common ratio. Okay, that is 9 by 3 is equals to 27 by 9 is equals to and so on. Okay, that is second term by first term, third term by second term. Then we say that it is called common ratio. If common ratio is equal, then we say that progression in GP. If difference is same, then we say that it is in AP. If ratio is same, then we say that it is in GP. Let us take the one more example. Suppose 5, 15, 45, 135, so on like this. A progression is given like this. Okay, that is 15 by 5 is same as 45 by 15 is same as 135 by 45, so on like this. Okay, which is equals to 3. This, if common ratio is same, hence we say that progression in GP. Common ratio generally denoted by R. Okay, that is given by the formula Tn by Tn minus 1. Tn stands for nth term, Tn minus 1 stands for n minus 1th term. Suppose if A be the first term and R be the common ratio, then the standard form of GP is A, AR, AR square, AR cube, so on, AR power n minus 1. Okay, A is first term, AR is the second term, AR square is the third term, this is first term, second term, third term, fourth term, so on like this is nth term. Means nth term of GP is A into R power n minus 1. Nth term of AP is A plus n minus 1 into D. Similarly, nth term of GP is A into R power n minus 1. Okay. See, what is the advantage to learn the nth term means, if you know the nth term, by using that we generate the remaining terms of the progression. By substituting n is equal to 1, 2, 3, 4 like that, we will get first, second, third, fourth, fifth terms. Okay. See, here we substitute n equal to 2 means T2, that is AR. See, the second term is this one. Next thing is, if you know the remaining terms of the progression, by using that it is possible to find out the nth term. It's a bidirectional statement. Okay, it's one of the important formula. Next, the sum of n terms. The sum of n terms of GP. See, the sum of n terms of GP is, we have several representations for sum of n terms of GP. That is Sn is equals to A into R power n minus 1 by R minus 1, A into 1 minus R power n by 1 minus R Na. Okay, these are the three representations. If R is greater than 1, okay, this is applicable. R is less than 1 if R is equal to 1. Right? If R value, common ratio value is more than 1, then better to apply the first formula for finding the sum of n terms, that is A into R power n minus 1 by R minus 1. If R is less than 1, then A into Okay, 1 minus r power n by 1 minus r. If r is more, then we subtract r minus of that. If 1 is more, we subtract 1 minus of r. Remember like that. If r is equals to 1, then we write it as Na. Okay. See, next sum of infinite terms of GP. Sum of infinite terms of GP. See, sum of infinite terms of GP S infinity is equals to A by 1 minus R. See, if R is lies between minus 1 and plus 1, means R value, okay, lies between minus 1 and plus 1, then only the sum of infinite terms of GP exist. Otherwise, sum of infinite terms of GP does not exist. Does not exist means infinity. Okay. See, this is also write it as minus 1 lies less than or less than plus 1, also write it as mod r less than 1. Okay. Sum of infinite terms of important condition. Sum of infinite terms of GP exist only r value lies between minus 1 and plus 1. Otherwise it is infinity. Suppose if r is more than 1 or equal to 1, r is less than 1 or equal to less than minus 1, then sum of infinite terms of GP is okay, does not exist. These are the main important formulas for solving any problem in GP. And after that we see that some properties of GP. What are the main properties of GP means? Let us take a simple example 2, 4, 8. What about these three numbers? These three numbers are in GP. Okay, common ratio is 2. For any three numbers are in GP, then it's satisfying the condition middle term whole square is equal to product of extremes. Not only 2, 4, 8, let us take 3, 9, 27. Okay, see middle term whole square 3, 9, 27 in GP. Okay, then middle term whole square is equals to product of extremes. For any three numbers are GP, okay, like A, B, C are in GP, then we write it as B square is equals to AC. Okay, and one more thing is supposed to say if A, B, C are in GP, A, B, C are in GP, then it is convenient to take A is equal to 1, B is equal to 2 and C is equals to 4. Same type of property we use at the time of arithmetic progression. A, B, C are in AP, then it is convenient to take the numbers are like 1, 2, 3. For GP we supposed to take 1 to 4 for solving some different types of questions. Okay, and the thing is, next thing is, suppose if A1, A2, A3, so on, AN are in GP, are in GP. And let us take a simple example 2, 4, 8, 16 are in GP. Okay, like 1 by 2, 1 by 4, 1 by 8, 1 by 16. See reciprocal sequence. Okay, a progression in GP, then the reciprocal progression is also in GP. Okay, see 1 by 2, 1 by 4, 1 by 8, 1 by 16 also in GP. That means finally we conclude that A1, A2 and so on, AN are in GP. Then what we write it as 1 by A1, 1 by A2, 1 by A3, so on are also in GP. Okay, right? Progression in GP, the reciprocal progression is also in GP. Remember that point. And one more thing is, suppose let us see this example 2, 4, 8 are in GP. Then what about log 2, log 4, log 8 and suppose that. Okay, see observe this middle term whole square is equals to, okay, sorry, 2 times of middle term. Let us calculate 2 times of middle term. See 2 times of log 4, can we write like log 16, and sum of extremes log 2 plus log 8, this is nothing but log 16, both of them are equal, means 2 times of middle term, 2 times of middle term equal to sum of extremes, means it satisfying the condition AP. And finally what we conclude that is A1, A2, A3 so on are in GP, then log A1, log A2, log A3 so on are in AP, not in GP. The point is if A1, A2, A3 so on are in GP, then log a1, log a2, log a3, so on are in AP. Remember this, okay, right? These are the property. This is the property. Next property is, suppose a format is like a plus AA plus AAA plus and so on, okay. See, it's not a into a, okay. For example, 4 plus 44 plus, a question is 4 plus 44 plus 444 plus 4444 plus and so on, like up to n terms. Then how to find out the sum of all these numbers, okay. See, it is equals to, just remember, see, a by 81 into 10 into 10 power n minus 1 minus 9n, okay. See, suppose one more format is like this, 0.a plus 0.aa plus 0.aaa and so on. A format is like this. And for example, a question is 0.4 plus 0.44 plus 0.444 and so on up to n terms. Then how to find out sum of those numbers? That is a by 81 again, 9n minus of 1 minus 0.1 whole power n. Actually, there is a proof for these two statements, but I am not interested to discuss the proof. In the examination point, proof is not required. Just remember the formula. Understand? Okay, and for suppose a question is 0.1 plus 0.11 plus 0.111 like this. What is the answer means? A means 1 by 81, 9n minus of 1 minus 0.1 whole power n. For suppose one more question is 0.4, 0.44, 0.444, so on up to n terms. Then we write it as a value is 4, 4 by 81, 9n minus of 1 minus 0.1 whole power n. For suppose a question is 4 plus 44 plus 444 plus and so on. What is the sum of n terms means? 4 by 81 into 10 into, because it is looks like the first property, not second property, 10 into 10 power n minus 1 minus 9n. These are the main properties of GP. Okay. See, now we discuss a few problems relating to how to find out sum of n terms. Okay, how to find out sum of infinite terms in different models. Okay, let us see this question. See the first problem. Okay, see, sum of n terms of the progression, sum of n terms of the progression 0.3 plus 0.03, 0.0003 and so on. Okay, right. See the question, what is a? 0.3, r value is 0.03 by 0.3. Hence, therefore, r is equals to 0.03 divided by 0.3. 0.1. Okay, r equals to 0.1. Is it less than 1 or greater than 1? Means it's a less than 1. Now, sum of n terms when r is less than 1, formula is a into 1 minus r power n by 1 minus r. A value is 0.3, 1 minus r is 0.1, sum of n terms means n by 1 minus 0.1, 0.3 by, see, observe this, 1 minus 0.1 means 0.9 into 1 minus 0.1 whole to the power of n. 0.3 by 0.9 means 3 by 9, which is equals to 1 by 3. 1 minus 0.1, write it as 1 by 10 whole to the power of n. Okay, therefore right answer is A. Okay, now next see the next problem, number 2. See, it's a very important model. Okay, the sum of the first 8 terms of GP is 5 times the sum of first 4 terms. Right? Sum of first 8 terms means S8 of GP is equals to 5 times of sum of first 4 terms, S4. Then the common ratio is, okay. See, first recollect the formula. What is sum of n terms? Is a into, okay, r power n means 8 minus 1 by r minus 1. In this problem, we don't know r value, whether it is greater than 1 or less than 1. You can take any one of those two formulas, whether it is less than 1 or it may be a greater than 1. There is no problem in the examination point. Right? This is equals to 5 into a into r power 4 minus 1 by r minus 1. Observe this, left hand side, right hand side, r minus 1 cancel and a gets cancelled. What are the terms? What is that expression is r power 8 minus 1 is equals to 5 into r power 4 minus 1. Now r power 8 minus 1, write it as r power 4 minus 1 into r power 4 plus 1 is equals to 5 into r power 4 minus 1. Now left hand side, right hand side, r power 4 minus 1 cancel. Therefore r power 4 is equals to 4. R square whole square is equal to 2 square. Therefore r square is equal to 2. Hence r is equal to plus or minus root 2. Okay, right? Hence answer is both. See Chennai. It's important question. Next problem is, see the question, sum of n terms of GP with first term 1, common ratio is 1 by 2. First term is 1, common ratio is how much? 1 by 2 is, means sum of n terms is 1 plus 127 by 128. It is a mixed fraction. Okay, first task is to convert the mixed fraction into an improper fraction. This is 1 into 128 is 128 plus 127, that is 255 by 128. Okay, now the question is, what is the value of n? Okay, Nandi. See here r is less than 1 and also we know that the sum of n terms of GP, just recollect the formula, what is sum of n terms of GP? Okay, that is 255 by 128 is equals to a into, అంటే 1 into 1 minus r 1 by 2 power n by 1 minus 1 by 2. That is 255 by 128 is equals to 1 minus 1 by 2 power n by 1 minus 1 by 2 means 1 by 2. 255 by 120 is equal to, this fraction is reciprocal, 2 into 1 minus 1 by 2 power n. Now take that fraction to this side, that is 255 by 256 is equal to 1 minus 1 by 2 power n. Therefore 1 by 2 power n is equal to 1 minus 255 by 256. 1 by 2 power n is equals to, this is 256. 256 minus 255, 1 by 256. 1 by 2 power n is equal to, this is 1 by 2 power 8. Both sides bases are equal. Now equating the powers, hence we will get n is equal to 8. These are the some different examples for finding sum of n terms. Now we are entering into sum of infinite terms of GP. See that question, sum up to infinity is of 1 by 2 plus 1 by 6 plus 1 by 18 and so on. See, in that question, a is equal to 1 by 2 and 1 by 6 by common ratio is 1 by 3. Obviously, it is lies between minus 1 and plus 1. Then sum of infinite terms of GP exist. That is a by 1 minus r. This is the formula. A value is 1 by 2 by 1 minus 1 by 3. That is 1 by 2 by 3 minus 1 is 2 by 3. This is 1 by 2 into 3 by 2, which is equal to 3 by 4, which is equal to 0.75. Therefore, right answer is A. Let us see one more example relating to sum of infinite terms of GP. Observe that it is not exactly looks like a GP. Okay. Now, first rearrange the given progression into standard form of GP. Observe that alternating terms for this progression. See, these alternating terms are like this. Okay, and observe these terms. Okay, Nandi. That is 1 by 2 plus 1 by 2 cube plus 1 by 2 power 5 and so on, plus write down the remaining terms 1 by 3 square, 1 by 3 power 4, 1 by 3 power 6 and so on. Okay, in these cases two different types of GPs are given. Right, see this, a is equals to 1 by 2, r is equals to 1 by 2 cube by 1 by 2, hence r is equals to 1 by 4. Here in this case is A is equal to 1 by 9, R is also 1 by 3 power 4 by 1 by 3 square is nothing but 1 by 9. Now we find out sum of infinite terms of GP, that is A by 1 minus R, 1 by 2 by 1 minus 1 by 4 plus 1 by 9 by 1 minus 1 by 9. This is 1 by 2 by 3 by 4 plus 1 by 9 by 8 by 9. 9 9 cancel. See, in this case 2 times cancel, which is 2 by 3 plus 1 by 8. Now the LCM is 24 is the LCM. 16 plus 3, which is equal to 19 by 24. See, answer is A. Let us see one more example for this GP. What the information is given is 1 plus A square and so on up to infinity value is x. Okay, 1 plus B square up to infinity value is y. Then what is the value for this expression 1 plus AB plus A square B square and so on up to infinity in terms of x and y? First of all, let us simplify the first expression. Okay, let us take the first one. 1 plus A square and so on up to infinity, this is x. Obviously it is in GP. First term is 1, common ratio is A, sum of infinite terms 1 by 1 minus A is equal to x. 1 minus A is equal to 1 by x. 1 minus 1 by x is equal to A. Therefore A is equal to x minus 1 by x. Similarly, what is B? Y minus 1 by y. No need to simplify that because there is no change between those two. First expression is A, second expression is B. Just we substitute B in place of A. Yes, next, now collect that as third one. Here what should we find is 1 plus AB plus A square B square and so on up to infinity. It is in GP, sum of infinite terms of GP, that is 1 by 1 minus AB. This is 1 by 1 minus A means x minus 1 by x, B means y minus 1 by y. Observe this 1 minus of, multiply this xy minus x minus y plus 1 by xy. Take the LCM and shift into the numerator, hence xy by xy minus xy plus x plus y minus 1. Both of them are gets cancelled. Xy by x plus y minus 1. Okay, next problem. It is also a sum of infinite terms of GP. Observe this progression. First simplify the first expression. X is equals to A plus A by R plus A by R square and so on. Okay, here first term is A, common ratio is 1 by R. Then sum of infinite terms is A by 1 minus 1 by R. Therefore x is equals to AR by R minus 1. Keep in mind. Similarly, let us take the next expression. See, from this y is equals to B minus B by R plus B by R square and so on. Y is equals to, here also first term is B and common ratio is minus 1 by R. Substitute that sum of infinite terms of GP formula. B by 1 minus of minus 1 by R is plus 1 by R. Therefore, BR by R plus 1. Keep in mind. Now coming to take the third one, Z. Z is equal to C plus C by R square plus C by R power 4 and so on. Here first term is C, common ratio is 1 by C square, remember, that is C by 1 minus 1 by R square. Therefore Z is equal to CR square by R square minus 1. Keep in mind. Now we want to find out XY by Z minus AB by C value is. Let us consider XY by Z. XY by Z is equals to, okay, what is X value? AR by R minus 1. What is Y value? BR by R plus 1 by what is Z value? CR square by R square minus 1. Now observe this in this expression, R into R square, in the numerator denominator cancel. Okay. Next, and also one more point, R minus 1, R plus 1, their product R square minus 1 gets cancelled in the denominator. Finally, what we get is xy by z is equals to ab by c. Therefore, xy by z minus ab by c equals to 0. Therefore, the final value for that expression is 0. Answer is A. Next, see the one more different problem in sum of infinite terms of GP. See, if S1, S2, S3, so on, Sn are the sums of infinite GPs. Okay, S1 is one sum of infinite GP, S2 is another sum of infinite GP, S3 is one more sum of infinite terms of GP, so on. Okay, with first term, S1 first term is 1, S2 first term is 2, S3 first term is 3, continuing like that. And S1 common ratio is 1 by 2, S2 common ratio is 1 by 3, continuing like that. Then what is the value for S1 plus S2 plus S3 and so on? Okay, now see that S1 first term is 1, common ratio is 1 by 2. For S2 first term is 2, common ratio is 1 by 3. Okay, S3 first term is 3, common ratio is 1 by 4. Now I am trying to calculating sum of infinite terms of GP, infinite terms of GP, S infinity is equal to 1 by 1 minus 1 by 2. 1 by 1 by 2 which is equal to 2. And therefore, S1 value is 2, remember that. Similarly, in this case is S infinity value is 2 by 1 minus 1 by 3, that is 2 by 2 by 3 which is equal to 3. Similarly, S2 value is 3. Now I am trying to calculating S3, S infinity is equal to 3 by 1 minus 1 by 4, 3 by 3 by 4 which is equals to 4, S3 is equals to 4. And therefore, what are the values we are getting means S1 is equal to 2, S2 is equal to 3, S3 is equal to 4, so on. Sn is equals to, remember, n plus 1. Okay. Now I am trying to find out S1 plus S2 plus S3 so on plus Sn, that is 2 plus 3 plus 4 plus so on plus n plus 1. These are n terms because of starting number is true 2 and ending number is n plus 1. From 2 to n plus 1 means we have n terms. Now I am trying to find out sum of these n terms. Observe that this progression is in AP because of the difference is 1. 3 minus 2 is 1, 4 minus 3 is 1, like that. Okay. Now and also we know that first term and last term and number of terms. Number of terms is n by 2 into first term plus last term, that is n by 2 into n plus 3, and therefore n into n plus 3 by 2. N into n plus 3 by 2, therefore right answer is A. Now next see the problem number 9. Okay, in GP if P plus Qth term is M, in GP TP value is, TP plus Q value is M, TP minus Q value is N. Now they are asking to find out what is TP. Okay, TP formula of GP is A into R power P minus 1. Okay, now we are trying to find out TP value by using these two equations. What is TP plus Q? A into R power P plus Q minus 1 is equal to M, and this is equation 1. A into R power P minus Q minus 1 is equal to N. This is equation 2. 1 into 2. A into R power P plus Q minus 1 into A into R power P minus Q minus 1 is equals to M into N. See, why I am going to calculate M into N means, observe that options. In the options we have an option is like Mn, that's why I am trying to find out Mn value. If it is not work out, then I am trying to calculating M plus N or M minus N. Now observe this, A into A is A square, R power, see bases are equal, powers are added, P plus Q minus 1 plus P minus Q minus 1 is equals to Mn. Okay, see this implies A square, R power, negative q, positive q cancel, p plus p 2p, minus 1 is minus 2, that is 2 times of p minus 1 is equals to mn. This implies A into R power p minus 1 whole square is equals to mn. This implies a into r power p minus 1 is equal to root of mn. See, this implies this is nothing but Tp is root of mn. Okay. Therefore, answer is A. Next, see the problem number 10. A power 1 by x is equal to b power 1 by y is equals to c power 1 by z. This is the given information. A power 1 by x is equal to b power 1 by y is equal to c power 1 by z. Then, and a, b, c are in GP. Then what is the value for then x, y, z are in? If any three numbers are equal to k. From this, a is equal to k power x, b is equal to k power y, c is equal to k power z. And also they given one additional statement, a, b, c are in GP. Substitute the a, b, c are in GP means b square is equal to ac. B stands for k power y whole square is equal to k power x into k power z. K power 2y is equal to k power x plus z. 2y is equal to x plus z. That means x, y, z are in AP. Okay. See, these are the some few problems. Those are there in your ICAI textbook. Okay. This concept is maximum sufficient to get the good marks in GP. Okay. Bye. See you in the next video.